All right, almost always. No, I have to say always up to now. I've said always do things in the right units, kilograms, meters, and seconds. Well, I'm going to show you a neat way to do this, a question like this. We could do this in meters and seconds and kilograms and work it out and get the right answer because physics is internally consistent. But I want to show you a neat trick, just using Kepler's laws to work out this one. We didn't actually need Newton at all. Now, Kepler's law, he realised that r cubed on t squared for any two bodies orbiting the same central mass is a constant. So if I've got, body A and body B, the ratio of their cube of their radius to the square of their orbit is equal to a constant. Now this question here, we're being asked about a satellite that's going to be placed in orbit around the Sun. So let's get our heads around this. Here's the Sun, here's the radius of the Earth, and we're being asked to put this new satellite here at twice the radius of the Earth, and we're being asked, what would its period be in Earth years? This is a great example of a way to use Kepler's laws just directly. So let's use the units that are most convenient to use. Let's consider radius, or the distance, in AU, or astronomical units. And 1 astronomical unit is the distance from the centre of the Earth to the centre of the Sun. It's the radius of the Earth's orbit. And let's consider time. Let's measure that in Earth years. Okay, so if we consider the Earth, its r cubed on t squared is 1 cubed on 1 squared, which is 1. Okay, so immediately the constant now for our solar system, anything with the Sun as a central orbit, is 1. So now we can say, let's start on this question here. We know that for this particular satellite, measuring in the units we're talking about, its radius is 2, and we're being asked to find its period. It's that simple. So we can say for this particular satellite, r cubed on t squared is going to be equal to 1, because it's going to be equal to 1 cubed on 1 squared for the Earth. Okay, so I can rearrange that and I can get myself my t squared equals r cubed, which equals t squared. T is going to equal the square root of r cubed, and that's how simple it is. So let's just pull this out. So I now want to find t. It's the square root of r, which is 2 power of 3, bang, comes out as 2.82 years. So it's 2.82 years, Earth years. So the orbital period is 2.82 Earth years. That's a really simple way to do these kind of questions, where you know what one satellite is and you're trying to compare it to another one. Usually the questions are giving you Earth as your reference and the Sun as the central body.